Let's have fun with FreeCAD again. I created this slider crank mechanism without much hassle. So let's put our minds together and create this assembly. Hello viewers, welcome to another FreeCAD Sys video. Today we are going to create this slider crank mechanism using FreeCAD Beta version 0.22. I created a similar assembly using Assembly 4 Workbench as I showed here, and it was a lot of work. And I had to use a lot of local coordinate systems and align the each body with those local coordinate systems, and it was a lot of work and a bit of a hassle. Okay, so this upcoming FreeCAD version 0.22, you don't have to do all these extra work, and it can be done pretty easily. And this assembly workbench is already available in ONDSEL. You can check that one out as well.
Okay, let's get going. I'm going to start this project by opening some components I created previously. So I'm going to go to that folder and I'm going to bring all these components which are part of the slider crank mechanism. So there are like 7 parts I created in FreeCAD. So we're going to just open all of them and you will see that they open up all these files. They'll open up separately. Now what I would do is I will create a file. Now I already have a file already created, so I can flip to that, or I can create a new one. Why don't I just close this one and create a new one? So I can, okay, so this is as unknown right now. So let's change the label to say slide crank. Okay. So what I will do is, let's see, this bearing, I'm going to just drag and drop here, and then I'm going to open this guy, drag the cylinder, and I can drag the crank, and I can drag the crankshaft, and then like so and so forth. I can pretty much drag all of them. Okay. Okay, this is the last one. Now, so pretty much all of these, all the components were bought into this. So there are like 7 or 8 components here. So all you have to do is just go and click on this and say close. Now there will be a message appearing, don't save them. Okay. So what happens is if you save them, this because this is an empty file, what we'll do is pretty much it will save or write over that empty file, and you will have to recreate the file from scratch again. So just close it without saving anything, or you can leave it as it is, but I would like to keep my workspace pretty clean. So that way I only have one file open up. So okay, so you can see that all the parts now are in this workspace I created. Okay, now what I will do is I will go to the assembly, and in this assembly workbench, which is different from the assembly 4 workbench we have earlier. So this has a lot of improvements. This is the FreeCAD version 0.22, which is in development right now, and that has this assembly workbench in it, which is quite versatile. And I have a tutorial that I put it in my previous video, where I gave you some, actually created some joints and described what all these joints are. So go and watch that tutorial. That tutorial should be like a prerequisite for this tutorial. Okay. Now, since I got all of them, I will create an assembly, and this is the assembly that I want to create. So I'm going to click on that, and it will appear at the bottom where you have this assembly. Okay, and it also has some joint button appearing, which we will talk about that in coming as we go along in this tutorial. Okay. Now, what I need to then do is to, since I have all these components, they are outside of this joint. Okay, they just, they are in this same workspace, but they are not part of the joint. Okay, right now. Now, what you need to do is to drag and drop all these components into the assembly, uh, and that will, once you do that, your assembly has the components in it, and now you can start creating the joints. Okay, so what I do is I just go and drag and drop this guy, dragging and drop them again. All the components that are or that should be in the assembly, you need to drag and drop. Okay, okay. Now all the components are in this. Okay. Now what you can do is pretty much you can spread them apart. You can drag him around. So got So what are the components I have? I have a piston cylinder, a slotted piston. I have a shaft or a crank, a shaft, bearings, uh, piston like a pin. So all these components are required for this slider crank mechanism. Okay. Now I need actually two bearings. So what I will do is I have one here. I copy and I say a copy, and then I go and paste in the assembly again. It will create another bearing here. You have to drag and drop it into your assembly. Now I can rename this as bearing 1 and bearing 2. Let me rename bearing 1, and this one I'll rename it as bearing 2. Okay, so you got two bearings because you need to have two bearings for the shaft. Okay, now you can start creating your assembly. Okay. Now this guy is all the items or the joints that you need to be using for this assembly. Okay. First thing you have to do is to start with grounding one component. A component that is stationary. Now the cylinder, as we know, is stationary, so you can ground this guy, and how you do that is select this component, and this is the button to ground this part. Ground means your all degrees of freedom in this component is you make it to 0. So maybe what I do is I click on this and say ground. Okay, now cylinder is grounded. So yeah, now it works. So everything else moving on, only the cylinder is grounded. Okay, now let me do this. Now, the next step is to, since you have the cylinder, now I want to put this, the piston inside the cylinder, and piston should only move either, it should move up and down or vertically. It should only slide, right? So you need a sliding joint, and this is the sliding joint that I will be using for that. Okay, so what I will do is I will click on this icon, and it's asked me to select the two parts. It's a slider joint. As you see, it's a slider joint. I need to select the two parts that should be inside this. Okay, so first I can click on this face on this one. It will create a like a coordinate system, and that coordinate systems in the center of the part. You can see it's in the center of the part, which makes sense. So it is intuitive enough to figure it out where that coordinate system should be. So I just click on that. It is created this, or it is actually pick a face and created a coordinate system. Now I need to do the same thing here. I can pick this face. Now joint is already created. The part was moved inside the cylinder. Okay. Now I can leave it as it is and close it. I think that's what I will do. Now you can see that it is inside. Now let me do one thing here. I can rotate this guy and I can maybe move this to the top. Yeah, so that should be good. Or maybe I can move it a little bit. Yeah, okay. I'll keep it as it is for now. Now, next thing is to put this pin inside this cylinder. Now, in order to do that, I would like to hide this cylinder. So what I will do is I will press the space bar and it will, at least it is still in, part is still there, but I just visually remove it. Okay. So now I need to have this pin inside this hole, and then there should be a join created for that, and it should be I'm going to create a revolute joint. The pin is free to move inside this piston, the whatever the hole is. Okay, so I'm going to create a joint, a revolute joint. Pick this guy, this surface, and I'm going to pick the surface inside the hole, and it will create it, but it doesn't, it only created somewhat it is kind of a protruding outside, so I need to offset this guy. So I will keep offsetting. Maybe I offset it too much. I would like to keep it centered around. Yeah, I think that should be good. Okay, I'm going to say okay. So there is the pin inside the piston. Now we have the three. So how many joints we have right now? We have slider joint, a revolute joint, so two joints already created. Now the next step is to have this crank with the piston. Okay, so we want to create another joint, another revolute joint that would join with this the pin. Okay, so let's create that. Let's create a revolute joint. And this time around, I want to pick this middle surface and I want to make sure that it is in the center of this mids or this hole. Let's see. Yeah, I think I'm going to click on that and click on this surface. Okay. Yeah, that worked. So joint was created. Now I'm going to say, okay, now of course it's not the direction I want to have it. This part should be uh, downward, not upward. So I can simply uh, drag it. Okay, I want to be vertical as much as possible. So we have it vertically downward. Okay. Now, okay, the next step is to align or create a joint between this uh, rotor and the crank. Okay. I'm going to pick, or I'm going to start with the revolute joint again, and going to pick joint. Let's see. Okay, so it should be, actually it is not. I need to redo that again and pick the outer surface, cancel it out. Okay, pick that joint. Yeah, I think I got it right. Let's see. So I'm going to say okay, and I'm going to yes. Okay. Okay, so you got that correctly aligned. So far I have one slider joint, three revolute joints created. Now, by the way, I only see one bearing, and there's another bearing. So I'm just going to drag it. Okay, so you can see there are two bearings here. It was just on top of each other. Now, next step is to basically create a joint between these rotor and the shaft. Okay. Now I'm going to create a fixed joint for that. So click on the fixed joint and just pick the middle surface here and pick on the surface or the cylinder. Yeah, that looks fine. Say OK. Now I got the shaft inside the rotor. So everything looks good so far. Now I need to assign the bearings to these two bearing mate faces. Okay. So once again, those are going to be revolute joints. I'm going to pick this surface and this surface. Maybe I did not exactly pick the surface I want. I'm going to cancel out, recreate it, because you have to have your coordinate system right inside and the middle of this surface, right? So that's the key. Okay, so then way it will align it properly. Let's see this. Okay, it worked. Okay, so same thing. I want to do the other side. Create a revolute joint. Pick surface and pick this surface. Okay, so we got the bearings also aligned. Now these bearings are the outer race is stationary, inner race you can rotate it, right? So you have to create a fixed joint for these two bearings. So to do that, you've ground them. Click on this guy. Okay, so grounded here. Okay, so you got the two grounded joints on these two surfaces. Okay, now I will go ahead and have the cylinder switch back on. So now when I rotate this, you will see this piston slides. Okay, so you can just try to rotate this guy. So piston starts sliding. So you can play around and see how this thing slides. So we pretty much created a slider crank mechanism using these joins. Can grow and see how that is translating. Okay, so you can play with this, but I think the message I want to get across here in this tutorial is that by just utilizing this set of joints with the combination of this assembly, you could create a set of joints without any, defining any local coordinate systems, because in the past I have created a similar tutorial, but I used assembly for workbench and it involved a lot of work to create the same slider crank mechanism, and this time around it was, I only have to use few steps to create this. So this shows that this assembly workbench that is built into this FreeCAD version 0.22, which is under development still, and which is already, this assembly workbench is already available in the ONDSEL uh, FreeCAD, and your life is much easier using this assembly uh, workbench than using assembly for workbench we used to have in the prior versions. We still have it here, but this is a much easier way to do and create assemblies in FreeCAD. Okay, I hope you learned something new here. This is somewhat more complicated assembly that we created here, and then I'm going to create few more things in the future. So please leave some comments what you learned, what you would like to see more in this channel, and I will get back to you with more tutorials coming up. So give us a thumbs up, subscribe. See you in next video.